Good afternoon, class. We are looking at exam 4, covering chapters 7 and 8. Chapter 7, systems of linear and nonlinear equations. Chapter 8, analytic geometry. We want to solve the system by substitution. As you can see, x has a coefficient 1, so we will solve for that. In general, if a variable has a coefficient 1 or negative 1, that would be the best choice to solve for first and foremost. So we're going to solve that, and it becomes negative 3 plus 9. We put it into the second equation, and we replace the x with that. We distribute the 4. We get negative 12y plus 36. Can add these two to negative 16y. We move the 36, we make it negative 16. And y becomes 1. You can put the y into the first equation, and x becomes 6. You should check it now with the second equation. We solve for y, again by substitution. We move the negative 4x. We put it into the second equation by replacing the y with 4x minus 19, and we distribute. We get 12x minus 57 on the left side. We can cross these two because they are identical. Is minus 58 equal to minus 58? That is a false statement. You can say F or false, and therefore there is no solution. If it's a true statement, it becomes an identity. In this case, we can multiply the first one by negative 3 if we decide to get rid of the y, or we can multiply the second one by 2 to get rid of the x. Makes no difference. So when we multiply this one by negative 3, we get negative 12x plus 3y and positive 21. These two cancel each other. And these two add up to negative 14x, and these two to 42. We divide both sides by negative 14. X becomes negative 3. We use one of those equations. For example, the first one, 4 times negative 3 minus y equals 7. This is negative 12. We move it to the other side. Becomes positive 12. Y becomes 5. We write the pair. It's a good practice to do that. Since we used equation 1, we are going to check with equation 2. Could you please read this question?
A bank loaned out $35,000, part of it at the rate of 3% annual interest and the rest at 11% annual interest. The total interest earned for both loans was $2,370. How much was loaned at each rate?
Perfect. It's a good practice to go with a table. So we have the amount, we have the rate, and the formula I equals PRT is the simple interest. So we have a total of 35,000. A portion of it, let's say X amount, is at 3% annual interest rate. The rest of it, let's say Y, is at 11% and we receive the total interest of $2,370. So look at the way we fill up the tables. Now, the amount of interest we get from here is I equals PRT. And by the way, T is 1 because it's annual. T is 1. So multiply these two, 0.03x, multiply these two, 0.11y, and these two must add up. These two must add up. X plus y is 35,000. 0.03x plus 0.11y is 2370. And as long as we have those, practically we are done. We can solve for y, for example. We put it into this second equation, 0.03x plus 0.11 times 35k minus x. We distribute. So when we multiply these two, we get 3850. When we multiply these two, we get negative 0.11x. Positive 0.03 and negative 0.11, they add up to negative 0.08x. We are going to subtract 3850 from both sides. We get negative 1480, and we are going to divide both sides by 0.08 negative, which makes it positive 1480, and we're going to add 2 zeros divided by 8. We end up with 18,500 at 3%. I can erase this part so it'll be clear. So x becomes 18,500, and the rest of it, in other words, 35,000 minus 18,500 is at 11% investment. Would you be kind enough to read this, please?
You need a 60% alcohol solution. On hand, you have 150 milliliters of a 10% alcohol solution. You also have 75% alcohol mixture. How much of the 75% mixture will you need to add to obtain the desired solution?
Perfect. So we need the mixture to be 60%, and we have 10% as well as 75% we want to mix it. So here's the setup. We have 10%, we have 75%. When we mix them, the result must be 60%. By the way, this number must always be between the two, and it is. So the strength obviously is 0.1, 0.75, 0.6 here. We have 150 milliliters of 0.1 or 10%. For 75%, we have X amount. And for the 60% or 0.6, we have the total of 150 plus X, or X plus 150. So that's the volume. That's the concept of a mixture problem. The total volume is constant. Therefore, what is the pure amount of alcohol in this case? Multiply these two, 0.1 times 150, multiply these two, multiply these two. And they must add up to the product of these two pieces. So 0.1 times 150 plus 0.75 times X equals 0.6 times X plus 150. And we are going to distribute this one. This becomes 15. This remains unchanged. This is 0.6x, and this one, 6 times 15 is 90. 1 0 and 1 decimal, they cancel each other. So we are going to move things around. We are going to subtract 0.6x here. We are going to subtract 15 here, and therefore we get a 0.15x equals 75. You can remove the decimals. And you get 500. X is 500. All right, we want to solve this question, and it's a system of equations in 3 variables. There are different methods, so we're going to go over one of them. Let's call them equations 1, 2, 3, so it makes it easy to refer back to them. We notice that if we add up these 2 equations, the y goes away. So we don't have to do anything, just add them up. And when we do that, they go away. This is 5x, this is 3z, and this is positive 1. Now, since we have used equation 1 and equation 2, we can use any of them, but equation 3 is a must. We have to use equation 3 with either the first one or the second one. So if we want to get rid of the same variable, by the way, we got rid of the y, we have to do the same thing. Over here, I can multiply this by 4 and this one by 3. So this becomes 9x minus 12y plus 6c equals negative 45. And this multiplication by 4 is 8x plus 12y plus 20z equals 80. These two cancel each other. And now we put them together, 17x, 26c, 35. And now the equation 4, which we created, and this one, they both have one variable missing, which is z, and they both are dealing with x and z. So we can put the two equations next to each other, and we can get rid of a variable of choice. For example, if I want to get rid of x, I multiply this one by 17, this one by 5, one of them negative. If I want to get rid of the z, this one by 26, this one by 3, one of them negative. So let's do that. We multiply this one by 17, we get 85x plus 51z equals 17, and this one minus 85x minus 130z equals minus 175. Obviously, these two cancel each other. And these two add up to negative 79z equals negative 158. And if we divide by negative 79, z becomes 2. You can use either equation 4 or 5. In this case, equation 4 results in x equals negative 1. Then we must go to one of the original ones. For example, equation 1 results in y equals 4. Therefore, we write the pairs as negative 1, 4, comma 2. Now, you can always use technology if need be to check your work. For example, I'm going to call this matrix B, and I'm going to put the augmented matrix 3, 2, 2. You see minus 4, 4, 3. See 2, 1, 5. I don't have room. And then you see the solution minus 15, 16, and 20. And if you run REF, reduce echelon 4, this is what it looks like, and you can change it to a fraction. However, if you use RREF or reduce row echelon 4, now this, as you can see, is the same as this one, and is the solution. Just wanted to remind you of matrices. We want to find the solution to this system, which is, of course, a nonlinear system. So we can substitute, since both of them are y, set these two equal. The ones cancel out. Bring them to the same side, factor out the x. So again, remember, ones cancel out. So we can bring minus x squared here, take the x, and this is 0 or 5. X is 0, x is 5. So if you go to equation number 1, y is minus 5x plus 1. So if I plug in 0, it gives me 1. And if I plug in 5, negative 5 times 5, negative 25 plus 1 is negative 24. Of course, if you're given the graph, you can, if it's pretty exact, you can figure out the points of intersection. Use the elimination method to find all solutions. So again, it's a system of nonlinear. Since this is equations, because this is 4y squared, let's multiply this one by 4. And we get 12x squared minus 4y squared equals 44. These two cancel each other. We get 13 squared. 13x squared equals 52. Divide by 13, x squared becomes 4. Therefore, x is plus minus 2. Now we use either equation 1 or 2. Perhaps 2 is easier. So if I replace it with 2 or negative 2, makes no difference. When I square it, I get the same number, namely 4. And so in this case, 4y squared is 4, y squared is 1, and y is plus minus 1. And it's important to recognize this means 4 answers, 4 pairs as follows. Negative 2 with negative 1 and positive 1, that makes it 2. Positive 2 with negative 1 and positive 1 makes it 2 more. A rectangle has an area of 102 centimeters and a perimeter of 46. What are its dimensions? So we are looking at the rectangle. Here's the width, here's the length, and we know the area is length times the width, and we know the perimeter is 2 times length plus the width. And so we use those facts. 2 times L plus W is 46. L times W is 102. Let's get rid of the 2. It makes it easier then for the substitution. I divide by 2 or multiply by 1/2. And I can solve either for L or W. And now if I put it in here, L times W becomes L times 23 minus L, which is 23L. Let's write it at the top of it. So and since I like this to have a positive coefficient, I'm going to move everything to the right. I end up with L squared minus 23L plus 102. And I want two numbers. The product is 102. The sum is negative 23, which makes both of them negative. There are two answers. L is either 6 or 17. And please understand, when L is 17, if I go with this one, 23 minus 17 makes it 6. If I go with this one, also the same thing. So meaning one is 17, the other one is 6. If by any chance one of them is negative, that is excluded. It's not acceptable. But it simply means if you choose length to be 17, then the width is 6. So in general, that's the final answer. We want to graph and find the solution. So first change this to equality and also this one. Now, all you have to do, pick up a couple of pairs to graph it. Those are called the lines of interest, the boundary lines. So for this one, if I choose x to be 0, y is 1. If I choose y to be 0, x is negative 1/2. In this case, if I choose x to be 0, y is negative 1. If I choose y to be 0, x becomes negative 4. So let's plug in those pairs. Let's plug in those pairs and graph the two lines. They are both dashed lines because we don't have the equality. Let's pick a test point. The best choice, if 0, 0 is not on the line, that would be the choice for that specific line. In this case, doesn't belong to any of them, so we can test them and see what happens. So if you plug in a 0, 0 into this one, that means 0 is larger than or equal to 0 plus 1. And that's actually just larger than. And that's a false statement. So that means if I were to come up with the answer, this can't be the answer. The opposite side will be shaded. We're going to do the same thing for the second one. When we plug in a 0, 0, 0 is less than a negative 1. And that also makes the second one a false statement. And for the second one, 0 is not a solution. So we make this side the solution. And as a result, the shaded region that they come together would be this. So this is blue, this is red, this is the only area which is both. So that would be the solution. All right, let's continue. We are interested to write the equation of a circle in standard form. In order to identify the center and the radius, so first and foremost, reminding everybody, if it's centered at 0, 0, x squared plus y squared equals r squared. If it's centered at h and k, x minus h quantity squared plus y minus k quantity squared is r squared. And in order for us to figure this out, we're going to put this one next to this one next to this one, and we're going to move the 21, make it negative 21 on the other side. We're going to make this a perfect square trinomial. B is negative 8. And divided by 2, so negative 4. Square that, and we need 16. And this one, B is 6 divided by 2, 3 squared is positive 9. So we're going to add positive 16 and positive 9 to both sides. This becomes x minus 4 squared. This becomes y plus 3 squared. And they add up. To 4. Therefore, the center is located at 4, comma negative 3, and the radius is square root of 4 or 2. Now, to graph the circle, let's look at the center and go 2 units or r units to the right and left, and r units or 2 units up and down. So right and left, up and down, put them together. Put them together. We'll write the equation of a circle centered at 1, negative 9 with radius 9. We already know the general formula is in the form of x minus h quantity squared plus y minus k quantity squared equals r squared. So replace the h with 1 and k with negative 9. So this is x minus 1 quantity squared. This is y plus 9 quantity squared. And r squared, 9 squared, which is 81. I'm going to sketch the graph of this elliptical shape. So first, x squared over a squared plus y squared over b squared equals 1. This is the a general case when the center is at 0, 0. If it's at h and k, x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Area is pi times ab, and b squared plus c squared equals a squared. Follows the Pythagorean theorem, where c represents the distance of the center from the each focus. And if A is larger, that means it's elongated along the x-axis in this format. If B is larger, you're going to interchange A and B. So in this case, clearly it's centered at 0, 0. A is square root of 36 or 6, and B is 4. So again, 36 results in 6, 4 results in 2, and you're looking at this equation. Therefore, the vertices are located at 6, 0 and negative. This is the center, and the vertices at 6, 0, negative 6, 0. Then from the center we go, so this is A units to the right and left. From the center, B units, 2 units up and down. And there you have it. Given the ellipse, find the center, list the vertices. Again, reminding everybody of that. It's centered at h and k, 2, comma 5, with a being square root of 9 or 3, b being square root of 16 or 4. So find the center point. I wanted to mention a and b. And to list the vertices from the center, since B is larger, so it's elongated along the y-axis. So we are going back to the center, and B units up and down. If I take it up, 5 plus 4 becomes 9. If I take it down, 5 minus 4 becomes 1, the same x coordinates. So bring the 4 here, add and subtract to the y coordinate. Write the equation of the ellipse in standard form, and again reminding everybody of this. So we are going to put x squared and x together. When we do that, we factor the 4 out. We get 4 times x squared minus 6. If we put the y squared and y together, so we factor out the 9 times y squared plus 2y, and the constant, we move it to the other side, becomes negative 9. Now, B, I want to make sure everybody can see this is B. Half of that is negative 3, and you square it, you add 9 to both sides. In this case, B is 2. So let's write that. This is B, B over 2 is 1, and B over 2 squared is 1. So you add 1 to both sides. Now, I wanted to show you that. Now, it's important to see that when we added 9, we didn't add on the left side. On the left side, we added 4 times 9. Okay, so we added 9 to the parentheses. So we have to add 4 times 9, or 36 here. And over here, when we added 1, we didn't add 1 to the left side. We added 9 times 1. We added 1 to the parentheses only. So 9 times 1, so we need to add 9. So now, of course, these two cancel each other. It's 36. And obviously, 4 times x minus 3 quantity squared plus 9 times y plus 1 quantity squared equals 36. Now, how do you make it look like this? You have to divide by whatever the number on the right side is. So if I divide both sides by 36, this becomes 1. What about this one? 4 goes away. This changes to 9. 9 goes away. This changes to 4. This is the standard form where the center is located at 3 comma negative 1. A is square root of 9 over 3. B is square root of 4 over 2. And those are the answers to the question. Identify A and B for the hyperbola with the equation x squared over a squared minus y squared over b squared equals 1. So I'm reminding everybody of the shape of a hyperbola. Equation x squared over a squared minus y squared over b squared equals 1. Y squared over b squared minus x squared over a squared equals 1. It opens up and down. And the asymptotes are in the form of plus minus b over a times x. If we keep the a squared under x squared and b squared under y squared, sometimes some texts they change them. So therefore, we also have a squared plus b squared equals c squared. Remember, this is the focal distance of focus, and therefore it will always be a squared plus b squared equals c squared because c is always larger than both a as well as b. And so in this case, we're going to identify A. So let's do this. This is what is called the fundamental rectangle. Let me just, so this is reminding you that this is called fundamental rectangle. And the purpose of that is when you draw the diagonals, those are the asymptotes. And so if you look at this point and this point, you can find the A. Again, this doesn't have to be to scale. You see number 2. So A is a 2. And over here and here is 4 and negative 4. So B is 4. So again, it doesn't mean that they have to have the same scale. So A is 2 and B is 4. Distance from the center to each focus is, in this example, and we notice it's a hyperbola because of this. And the center, according to this format, is located at 7, 3 with A being square root of 4 or 2, and B is 1. The reason is because when we don't have a denominator, the denominator is 1. Therefore, B squared is 1 and B is 1. So that's the thing. And if we calculate the value of C, that's the answer to the question. And in the case of a hyperbola, a squared plus b squared is always equal to c squared. So 4 and 1 is 5. And the c is square root of that. Write the standard equation for the hyperbola. Again, we have a bunch of equations here reminding everybody of what we have. So we notice it's centered at 0, 0. We have this, again, fundamental rectangle, and it's opening sideways. So we do have this type of a formula. And this distance gives us A. Centered at 0, 0, this distance gives us A. This distance gives us B. A is 3, B is 6. And so simply put x squared over a squared or 9 minus y squared over b squared or 36 is 1. So this fundamental rectangle helps us find those points. And again, look at the diagonals. Find the focus, directrix, vertex, and axis of symmetry for the parabola graph. Include the directrix and focus with your graph. So if I put it in a standard form that we learned, first of all, a couple of formulas. You remember this from algebra, elementary and intermediate algebra. And this is when we want to go with the focal distance. Remember, by definition, if you pick a pair on the graph of a parabola and connect that to the focus and the directrix, they have the same distance. That is the definition. And this distance is called focal distance, or this distance. And if you go across here, its lattice rectum, which is 4 times p. Sometimes they call it a, the focal distance. And so these are different formulas that you've seen. You can use those formulas and follow that. One easy way I find, if I solve for y, that means I'm going to divide by negative 1/8. So I get 1 over negative 8. And then we move the 2. I want to put that in a standard form in algebra because that really, I think, makes it easier to follow. And that is, first and foremost, the vertex is located at negative 1, comma 2. And this is the value of a. And we know the relationship between a and p is that a is 1 over 4p or p is 1 over 4a. Now, if you look at this one, the concept, and I'm going to erase that just to give you an idea how you come up with everything. So the graph looks something like that. This is, again, we will look at more details. This is the axis of symmetry. And we have a directrix. So somewhere here, let me use a different color. Somewhere here, we have the focus. And somewhere here, okay, somewhere up here, maybe here, or maybe here, we have a directrix. So we know since this opens down, then from the vertex, you go down by the focal distance and you find the coordinates for that one, and you go up and you find the equation, which is y equals some number. So the reason I'm drawing this, I just want to make a point. So when you draw it and it's not to scale, it gives you an idea how to finish the job. So first and foremost, a is equal to negative 1 over 8, and it opens down. So that's roughly the case. The vertex is negative 1, negative 2. Okay, so that's where the vertex is. Since a is 1 over 4p, then p is 1 over 4a or 2. And simply put, look at the vertex. I'm going to go down by whatever this number says to find the focus. So in order for me to go down, that means I keep the x coordinate negative 2 minus 2 gives me minus 4. That is a y. We have minus 1, comma, minus 2 minus a p. That's the location of a focus. And for the directrix, we need to add p. So y equals 0. And that's the axis of symmetry. And I'm going to clean up the mess. Looking like that. And the graph. Very straightforward. Could you please read this question?
A satellite dish is shaped like a paraboloid of revolution. This means that it can be formed by rotating a parabola around its axis of symmetry. The receiver is to be located at the focus. If the dish is 80 feet across at its opening and 5 feet deep at its center, where should the receiver be placed? A. Find the equation of the parabola.
Perfect. First and foremost, assuming a parabola, this is the vertex at h and k. This is the line of symmetry. Okay. Somewhere we have the focus. That's where this is located. And this is the focus. We have this distance of 80 feet. And we have the depth of 5 feet, none of which is to scale. Now, where is the vertex at? To make life easy, you can let either vertex be at 0, 0, or you can let this line be on the x-axis. It is absolutely up to you. So, and I'm reminding you of those formulas. So If we go with 0, 0, then we can go with any of those formulas we have seen. Remember, it's a parabola that opens up. That's the way we have created it. So y equals a times x minus h quantity squared plus k. That means basically a times x squared, and there is no k. If you want to go with this method, okay, by the way, this one has coordinates 45. This one has coordinates minus 45. I hope you realize that because we said this distance is 80. So this is the one we're going to use. You can say y is ax squared or x squared is 4py, either way. Again, we could say just the way we did it. I hope you remember that we could say y equals ax squared, and the relationship between a and p is that one of them is 1 over 4 times the other one. Okay, so for example, a is 1 over 4p. So all you have to do, plug in the pair. Plug in the pair. Meaning either this pair or doesn't matter, this pair. So if I replace the x with 4d, I must replace the y with 5. This is 1600. This is 20p, and I'm going to divide by 20. And the focal distance, this distance is 80 first and foremost. The equation of x squared equals 4py is x squared equals 321. And then I'm going to put it 80 feet above. Okay. So how far above the vertex, that is the answer, regardless. However, assuming the x-axis is at the rim of the dish right here. So if this represents the x-axis, class, then the equation becomes x squared equals 320 times y plus 5, because the vertex in this case is located at 0, -5. In case, you don't have to do that, but just wanted to make sure we are comfortable with that. We want to write the system of equations as an augmented matrix. Basically, what it means, write the coefficients. So -4, -1, 3, 4, -8, -2. You can go column-wise or row-wise, okay? For this one, the column I would write -5, -10, 8, -2, 1. No, I'm sorry, D is missing. D is missing, and that's important to pay attention to. So this one, let me just rewrite this: -5c plus 0d minus 2s. So it really is important to pay attention to that. So this, for example, this row becomes -5, 0, -2, 100. This one becomes -10, 1, -4, 150, and the last one becomes 8, 1, 3, 200. So pay attention to the fact that there is a missing variable, and you got to account for that. Find the reduced row echelon form of this augmented matrix. So basically, you put that into a matrix format in TI. I have the command here. I had already given it to you. So you go with the matrix editor, you choose the size, and you plug in. And then you go with RREF, and it gives you the answer, which means basically just this is the reduced row echelon form of this augmented matrix. This normally represents a system of equations, and the last column represents the solution. The given matrix is an augmented matrix representing a system of linear equations. Use the Gauss-Jordan elimination method to find the solution of the system. Of course, we can go through the process of that by putting this into the A matrix, right? Editing it. And then RREF results in the answer. So what is the solution? That's the solution equivalent. Use a method to find the solution. So you want to write minus 1, minus 4, minus 3 here. So you want to write this here in essence. Write the system of equations as an augmented matrix, then use the Gauss-Jordan method to solve for x and y. So first and foremost, this is minus 3, 4, 15. This is 6, negative 1, negative 30. And normally, I mean, you may do it with technology, but if you were to do it by hand, the methodology is to first and foremost make this one 1. There are different ways. One easy way, if I multiply everything by negative 1/3, I will change this to positive 1. And so this becomes, so negative 1/3 R1 goes to R1. That's the meaning of this arrow. So this becomes negative 4/3, and this one dividing by negative 3 in essence gives you negative 5. The next step is to make this one 6, to change it to 0. Okay, so number 6 be 1. So first thing first, you make this one 1, everything underneath 0. Then you make this one 1, and everything at top and the bottom 0, and you move on. That is the methodology. So if I multiply this one by 6 and subtract it from this one, this becomes 0. So minus 6 R1 plus R2 to the R2 makes this one 0. So if I multiply this one by negative 6, I get positive 24/3, or positive 8 with negative 1 gives me 7. And if I multiply this one by negative 6, I get positive 30, and negative 30 is 0. The next step is to change this to 1. So here's the next one. I'm going to divide this row by 7. And so what happens, the first one is intact. This becomes 0. Divided by 7 is 0. 7 becomes 1, and this becomes 0. Now, the last thing is to make this one a 0. And to do that, you add 4/3 of R2 to that. So when I multiply this one by 4/3, this remains as 0. This remains as 0, but this one changes to 4/3. When I add them to the first row, these two don't change, but this one changes to 0. And therefore, it gives me the answer, which is minus 5, 0. That is the solution. However, if you do the matrix, which is a 2 by 3 matrix, and then REF, you will find the solution right here, and that's exactly what we have.